Hello, Pre-Algebra students. Mr. Lawrence here, and we're going to be learning about similar polygons. We talked about them in class a little bit today. The definition of similar polygons. They are the same exact shape, but different size. Consequently, this means that their corresponding sides will be proportional. Now, why do I put same exact size? Because you could have a triangle that looks like this, right? Probably an isosceles, maybe equilateral. But then I could have a right triangle like this, okay? And, you could argue, well, they're the same shape. They're both triangles, but they're not the same exact shape. One is a different type of triangle than the other. So these two can never be similar, okay? If you're going to be talking about triangles, then they have to be the same style of triangle. For example, I could do this one, and then I could do, let me clone him. I always like to do this. And you see how their angles are exactly the same, right? The angle measures have to be exactly the same. Okay, those are probably similar triangles. I can't really be sure unless I check the corresponding sides. But let's get down to it. I'm telling you that these two pentagons are similar. I want to see if you can find the measure of angle x. Well, I'm going to set up a proportion because the corresponding sides are proportional. I've got a lot of different ways to do this. Some people will go like, the short side over the long side. So their first fraction will be 6 inches over 10 inches. Okay, and then they'll have to be consistent. The unknown side, which is the shorter of the two, over the 25, right? That is one good way to do it. That is not the only good way to do it, though. I can think of at least 4 different ways. I'm not going to show them all, but I'm going to show you this one. Some might go this side over x, and then of course you have to do the 10 over the 25. It doesn't matter as long as you match up the corresponding sides. Okay? When you go to solve them, you'll get the same answer either way. Look at this. When I cross multiply my proportion, aren't I going to get 6 times 25? Right? On the left-hand side here, you see the 6 times 25? And here, let me do this. Maybe you can't tell what I'm doing there. I'm going to multiply 6 times 25, and I'm going to multiply 10 times x, right? But over on the other one, aren't I going to multiply the 10 times the x and the 6 times the 25? So you see I'm going to get the same problem no matter which one I use. I like to do it the way it is on the left, but again, there's lots of different ways to do it. So I'm going to do my cross multiplication right here. And I'm going to do 10 times x, and that'll get me 10x. 6 times 25, well, if I had 6 quarters, I'd have $1.50. I'm going to divide by 10, and x is going to equal 15 inches. Okay, notice I didn't use the 7. The 7 I put in as extra information to see if you would match up the corresponding sides. If I want to use the 7, and maybe I want to figure out this side here, I don't know, we'll call it y. Now I have lots of options on how to set this up to find y. Okay, I'll have to decide which sides of the pentagon I want to use. I could set up a proportion. Let me get my highlighters out here. I could set up a proportion using the 6 over the 7, in which case I do the 15 over y. That's one good way to do it. Or I could do the 10, use the 7 and 10, in which case I'd have to use the 25 and y. Lots of different ways to do this one. I'll tell you what, I'll use the 6 and the 7 because it's the one that occurred to me first. And I'm going to go ahead and do left side over right side. So in the first pentagon, my left side is 6 inches. The right side is 7 inches. And I'm going to do left side over right side on the other pentagon. So I'll do 15. And I'll put that over y because I don't know. Cross multiply. I'm going to get 6y. 7 times 15, I think, is 105. Yeah. and then I'll divide by 6, divide by 6, so 105. Of course, you can use a calculator. Divide by 6 is going to go 6, 45, 7, 42. So it gives me 17.5, 17 and a half. Oops. So y is going to equal 17 and a half inches. All right. There you go. Pretty easy stuff. 17 and a half inches. All right. I'm going to come down here now. And I want you to test and see if these two rectangles are similar. You can't just look and tell. What you have to do is set up a proportion. So I'm going to do 5 over 12. Does that equal, notice I did short side 5 over long side, so I got to do short side over long side. All right, well, let's see if they're equal to each other. What will I do? I'll cross multiply. Because if they're equal, the cross products will be the same. 18 times 12, I'm going to get 6. I'm going to carry the 1, 2, 10, 1, 11, the 1, 216. Is 24 the same as 216? No, it is not. Therefore, these are not similar. So to determine if two polygons are similar, I found the cross products. I set up a proportion and cross multiplied. If I get the same number on both sides, then they are. But in this case, they're not. Okay, one last sample problem for you. Aktahab Mit is 6 feet tall. I think I'll draw him. Here's my friend, Aktahab Mit, and he's 6 feet tall. I know that that is 6 feet. Okay. Standing next to a tree. I think I need my tree. Oh, now you know why Mr. Lawrence teaches math, not art. And he notices that his shadow, let me put his shadow in, right there, his shadow is 18 feet long. Okay? And he notices that the shadow of the tree, I'm going to change the color there, the shadow of the tree is 45 feet long. 45 feet. So that's the shadow of the tree, right? Well, he wonders how tall the tree is. Do you see it? Do you see it? I see it. I can see it. I really can. I'm so excited. There are similar triangles right there. See the similar triangles? We've got Mit-Aktahab's triangle, which looks like this. And that side's not really there, so I'll just make it a broken line, right? And then we've got the triangle for the tree, which looks like that, 45x. To figure out how tall the tree is, I'm going to set up a proportion. I'm going to do 6 over 18, and that's got to equal x over 45. All right, so now I'll cross multiply, 18x. That's going to be 45 times 6. Well, let's see here. If I double, I get 90, and I get 3 90s. That's 270, I think. I think that's right. Yeah. Okay. So then I'm going to divide by 18. Divide by 18. And 270 divide by 18. Okay, I think that's going to be 90. Oh, maybe 5. Yeah, 5. 5 times 8 is 0. 90. Yep. Okay, so x is going to be 15 feet tall. That's how tall the tree is, 15 feet tall. Now, one thing I want to point out to you, x is 15. Check this out. How do I turn 6 into 18? I'm going to multiply by 3. Can I turn 15 into 45? Sure I can by multiplying by 3. See, that works if the triangles are similar. Okay, that's your lesson for today. Let's just quickly review. Say we can find the missing side of similar polygons. We know that similar polygons have the same exact shape, different size, which means the corresponding sides will be proportional. We're sure to set up, be consistent. You know, if we do 6 over 10, we have to do 15 over 25. Okay, if we do 6 over 7, then we have to do the 15 over the y, right, which is 17 and a half. If we have two polygons and their measurements, to determine if they're similar, got to make sure the same exact shape. Well, they're both rectangles, but then we set up a proportion and cross multiply. If we get cross products that are equal, they're similar. If the cross products are not equal, like in this case, they're not equal. And then finally, we did a story problem. And I know some of you think story problems are difficult, but actually the story problem was pretty simple, wasn't it? We drew a picture of our friend Mitt, we drew a picture of the tree, we showed how long the shadow was, and we said, hey, we've got similar triangles. And because of that, we were able to figure out how tall the tree was. So in this case, the tree is 15 feet tall. All right, that's your lesson for today. Mr. Lawrence signing off. Good night, everybody.